When I was a student, I read a fragment of a Greek philosopher, Heraclitus. It was a long time ago, but the phrase stayed with me. Nature loves to hide, it said. Just that. Does it perhaps mean that the law which governs everything we see is invisible to our eyes? In which case, everything that is apparently there before us is hiding from us at the same time. But then, how can we know it?
We may have a whole elephant here, and we just don't see it. Because we don't have the eyes or the questions to explore that particular part of nature. The universe somehow has given us a shock. It's a shock therapy.
We who 100,000 years ago were apes, basically, wandering around the African savannah, we are able to understand so much about the way the universe works. But it could be that something completely unexpected shows up. We're just looking where human beings have never, ever looked before.
Anni fa, 12 Paesi membri firmarono la convenzione che stabilì la creazione di questo Consiglio europeo per la ricerca nucleare. L'atto di convenzione è un documento bellissimo nella sua semplicità e nella sua visione. Qualche paginetta in cui si stabiliscono 3 aspetti. Un laboratorio per fare ricerca in fisica fondamentale. I risultati devono essere disponibili all'umanità, messi a disposizione di tutti, e in questo laboratorio bisogna favorire la cooperazione internazionale. Questo scopo di pace in realtà è insito nell'atto fondatore stesso del Cern, negli anni in cui l'Europa usciva travagliatissima da una guerra molto, molto sanguinosa.
The first time I came to Geneva, it was almost by chance. The European Centre for Particle Physics was in the throes of an epoch-making experiment. I was in the celebrated citadel of science, but I was rather disappointed. My first impression of Cern was of an unattractive industrial suburb. In those early days, I got a call from a friend who worked at Cern who had managed to obtain authorization to enter the Great Particle Collider, the LHC. "We can go down into the cavern," he said. It was here, in this tunnel over 100 meters below ground, that in the summer of 2012 the Higgs boson was captured, the God particle. Physicists don't approve of that term, but it does convey the idea. Thanks to this discovery, a theory has been verified which explains with remarkable precision everything we can see in the universe.
The one thing in human history which I find the closest to what we do are the Gothic cathedrals. We don't really know who is the main author. We are all main authors. I mean, I'm the spokesman, but I don't count more than all the others. Each one has made the little statue, one has made a glasswork, and in the end, the result has grown over a very long time. Maybe they take 100 years to make such a cathedral, and the result is harmonious, it's beautiful.
Qui lavorano 11.000 scienziati di tutto il mondo, 100 nazionalità differenti, provenienti da paesi che si fanno la guerra o che semplicemente non si riconoscono il diritto all'esistenza. C'è una grande passione per la conoscenza. E questo è un linguaggio universale che trascende la razza, la religione, l'età, il genere.
Noi siamo uno dei pochi linguaggi di pace che l'umanità è riuscita a inventare. Forse la musica. Siamo stati appunto ammessi dopo 60 anni come un'organizzazione, come osservatori dell'ONU, con diritto di parola, ma non di replica.
Questa comunità non vive per l'interesse personale o per arricchirsi o cercare dei vantaggi personali, ma vive di idealismo, se vuole, del bisogno di conoscere. Si può vivere di conoscenza.
Cern is a community gathered around the invisible. The people who make up this community are united by a common passion for nature made not of concrete objects, but of pure energy. They deal with issues that may seem very far from everyday life. Yet here, in November 1990, in this little ground floor office, the World Wide Web was conceived. If the internet is now free and accessible to all, that is due in large part to the fact that Cern was born out of a great European ideal, whereby all knowledge must be shared and placed at the world's disposal.
Today is also a special day because we hear two presentations from the two experiments, Atlas and CMS. We should state it. We have a discovery. We have observed a new particle consistent with a Higgs boson.
Peter.
To the extent that I am made of fundamental particles, does this not have any relevance to me?
I think it has a lot of relevance to you because if that would not exist, I think you would not exist.
La prima volta che si è parlato di LHC è il 1983. Non è diventato un oggetto vero sino alla fine degli anni 80. Nessuno pensava fosse possibile costruire 1300 magneti lunghi 15 metri, fatti in maniera industriale, con un campo di 8 Tesla e mezzo, che funzionavano a 272 gradi sotto lo zero. Però dietro c'era una visione.
The LHC ring and its detectors are the largest machine ever made. But it is a machine unlike any other. It doesn't make anything. It isn't part of any production process. For me, it's a poetic machine because it is not useful. All it can do is look for answers. It investigates a mystery where the words and images with which we are familiar can no longer help us.
Questa è di fatto una grande macchina fotografica, pesa 13.500 tonnellate, ha 100 milioni di canali che possono fare 40 milioni di fotografie in un secondo. Se uno li scrivesse su dei DVD, in un anno uno farebbe una pila di DVD alta 5 volte il Monte Bianco.
Everything we see is made of invisible particles, of which we possess no concrete image. Like hunters, physicists look for tracks, the prints left by energy that reveal their existence. Some of them we can discover only indirectly from the traces left by other particles. Here the word imagine no longer means to look for an image. These are the paths followed by the particles in billionths of a second after a collision. They are the only pictures that the LHC can take.
If we were able to see at the same time atomic phenomena and cosmological phenomena, our brain will probably explode. We only see something like an averaging of all these structures, and to be able to see this extraordinary complexity, we have to use machines.
Mia madre spesso mi chiede, ma queste particelle le vedete o non le vedete? E se non le vedete, come fate a dire che esistono?
Non c'è spessore, non c'è odore, non c'è colore. È un qualche cosa di... È il vivere nel mondo quantistico, che è un mondo che noi completamente non immaginiamo.
Le leggi fisiche, come si conoscevano nell'Ottocento, corrispondono alla nostra percezione comune. Le leggi della meccanica quantistica invece sono paradossali, quindi ci sembrano lontane dalla realtà. La cosa bizzarra è che la realtà invece segue le leggi della meccanica quantistica. Quella è la vera realtà, perché è lì che andiamo a scoprire l'essenza della natura. Uno dei risultati più straordinari dell'esplorazione del mondo fisico è stato dimostrare che esiste un ordine nella natura. E quello che ci spinge dalla ricerca della fisica delle particelle è la convinzione che questo ordine emerga in modo sempre più evidente, scendendo distanze sempre più piccole. Una particella può esistere in stati diversi simultaneamente. Cioè tu potresti esistere sia avendo un maglione rosso, un maglione verde, nello stesso tempo. Nel momento in cui ti guardo e vedo che hai un maglione verde, ho determinato il tuo stato.
It's hard to accept that nature is in its essence so undefinable, and that only when we observe it does it take on a precise state. And yet from nature so indeterminate emerges the world that we know, so solid, reassuring. A jetty, an apple tree in blossom. Artists and physicists find out that they can no longer describe nature directly, using recognizable images. We are used to seeing elementary particles as coloured balls, atoms as miniature solar systems. But these images are nothing like the real thing. Images of something we cannot see. There are artists who are inspired by the discovery of physics to imagine the invisible.
The way things look and the way things are very, very different. We are like a man standing on the top of a cliff looking out to a sea where he can see a horizon, but only imagine what lies on the other side. We are left in this place where, we know about our own lack of knowing. This, for me, is a huge, source of inspiration.
The LHC ring is being prepared for the experiment. Hundreds of millions of data acquisition channels are synchronized to a billionth of a second. But this experiment is very different from the previous ones. There is no theory to verify. It's a hunt for tracks. in the hope of finding something.
We're jumping to a new level because we're increasing the energy to levels that have never ever been produced in a laboratory. So we really don't know what we're going to see there. And I personally hope that we're going to see something completely unexpected.
Entriamo a toccare le più grandi domande che sono sempre state lasciate aperte. Che cosa c'è dopo, che cosa c'è oltre quello che conosciamo. Stiamo andando a toccare i processi che hanno generato la materia così come la osserviamo.
We understand 4%, maybe 5% of our entire universe. That's a big problem. We need to solve that. What's the other 95, 96% that's out there? We need a hint.
La prima volta nella nostra storia, se vuole, negli ultimi 60 anni, siamo trovati senza una via maestra, quindi adesso stiamo veramente guardando su ogni sasso, cercando disperatamente dove è la nuova fisica.
This is a real event. This is what actually happens in the experiment. In the very center, you have the point where the two nuclei hit each other. It is the densest and hottest thing that humans have ever observed. Is the closest thing to the Big Bang. We are going backwards in time until a few microseconds, few millionths of a second from the Big Bang, and then we observe how matter evolved from them.
Big Bang, recreated inside a machine. A time machine in which the history of the universe goes backwards in the freezing darkness to a tiny pinhead from which everything apparently began.
Really like to see something completely unexpected, really blowing our minds and causing us to rethink the way we view the universe. That to me would be the most amazing thing in the whole world.
We could get lucky. We could discover new particles like supersymmetry. We could discover dark matter.
La prima cosa che tutti andranno a cercare è di trovare evidenza per la supersimmetria. E io sono molto ottimista.
I think it's one of those moments in history where we really have no clue. There are all these things that we have imagined. But normally, nature is far more imaginative than physicists. So one thing that we would like to see is precisely nature showing some of its remarkable imagination.
What are we? Where do we come from? Where are we going? I had that painting on my wall just to remind me every day when I came into the office why I was coming to work. I mean, artists, like scientists, are trying to understand the human condition, what's going on in the universe around us. Gauguin, tried to describe this in his famous painting, and our impulse is very much the same. Of course, we use different tools to address perhaps similar metaphysical problems.
The veritable crossroads of art and science is a revelatory experience. A beautiful scientific experiment is indistinguishable from an artwork.
The sense of excitement I can feel in the air is contagious, liberating. Slowly, the liquid helium cools the 27-kilometer ring down to a temperature of 272 degrees below zero. On Easter Day, an electrical current equivalent to the consumption of the entire city of Geneva switches on the LHC. Just like artists, physicists need to use their imagination to get closer to the truth. Before every experiment, there is an intuition, a question. This time, however, we are facing the mystery. It's like going into a dark room without knowing what awaits us.
Atoms and molecules are actually dynamic entities. They're in perpetual motion. And so on the atomic and molecular level, the entire world is actually a massive perpetual motion machine. Our entire lives, our reality is actually embedded in this interlaced matrix of energy fields that's on a level that's invisible to our eye. My human body is a fancy energy field that is made from the same building blocks as any other object in nature. And in that sense, we all come from the same material. So the motion of any given atom in the system depends on and affects the motion of millions of other atoms in its neighborhood. So you start to imagine a sort of dance on a stage. So this sort of insanely interconnected, interlaced choreography.
we'd like to tune to objectless world of nature. And although these things are invisible, we can sense them, we can experience them. So we just want to amplify this experience and tune to it. We are interested in certain wave behaviors and visualizations of them and having it live in front of the observer.
Matter and energy are dimensions of each other. Space and time are dimensions of each other. As a sculptor, how do I lose my determinism to shape particular bits of matter and acknowledge the fact that everything is in flux?
Noi siamo abituati nel nostro mondo macroscopico a usare dei sensi, i nostri 5 sensi, che ci permettono di interfacciarci con la realtà, e questo è il modo con cui noi approcciamo la realtà. La meccanica quantistica ci ha aperto un mondo che non può essere visto con gli occhi con cui vediamo la realtà macroscopica.
I don't think in our common language we have metaphors for the subatomic world. We visualize it as Galileo was telling us with mathematics. Then you have to use the language of mathematics and, of course, experiment to get a picture, if you like. But the picture is not something nice with people, with a landscape and the mountains and so on. It's something which you really have to learn.
Math is just a language like any other, French or English or what have you. And so when a physicist comes up with a relationship like we do, it's not too far different from a poet writing a poem or an artist painting a picture. It's just our medium for creativity.
Linguaggio come la matematica, io dico che lo puoi soltanto scoprire, nel senso che è qualcosa di intrinseco alla natura. Il fatto che la natura usi veramente per esprimersi un linguaggio matematico significa che c'è qualcosa di più, non è soltanto una costruzione umana, intellettuale, bensì una vera realtà della natura, è il modo in cui la natura si esprime.
To cross the threshold of the invisible using numbers, it seems absurd. And yet, as in a mirror, human beings too replicate the mathematical structure of nature. When we record images, we use quantum mechanics and digital codes. This Mont Blanc is really just a long series of ones and zeros, stored in a memory.
Art, like science, is saying, try looking at it this way. Can we conceive of the world being constituted like this? And if so, what does that change?
One thing sonification can do for us is let us hear things that would normally be inaudible. There are patterns and cycles in the universe that happen at such a slow rate, like longer than a human lifetime. And at the other end of the scale are things that take place in yoctoseconds or septillionths of a second. Then we would never be able to perceive those things. I think time and the sequence of things is a really strong perceptual cue to people, to humans. And I think we almost, without even intending to, we think of things that are happening in a sequence. We give it a kind of a narrative almost. And then only a few. So each line in this file corresponds to one collision that they had gathered data from. Here, you hear that kind of low, mysterious sound. That frequency is about here. But then every once in a while, for some of the GeV values, you'll see a different frequency pop up, like these there. Every little particle that you heard there was an echo. And it creates almost a reverberation effect, like the little echoes you hear from the walls in the room.
Sound is much more complex than vision, and sound can overcome some of the visualization issues, where, for example, we cannot imagine two things to take the same physical space. We can imagine two sounds to take the same physical sound space. This is the energy of the particle. And the energy is then translated into these numbers that are music notes, basically. Something that comes from physics, from the LHC, from the very core, very inner nature of matter.
When humans went to space, the sense of beauty, interconnectedness, and harmony was so apparent to astronauts being outside of the planet that they all share this great feeling of revelation. And when you're floating in this dark, empty space that they characterize like the black velvet, the immense sense of beauty dawned onto them.
The tests are over. It's time to attempt the great experiment. The first collisions at an unprecedented high energy. At a depth of 100 meters, the LHC ring must be completely sealed off. On the surface, the experiment is monitored 24 hours a day in the control rooms.
Start power group 56. Start power group 57. Start power group 58. Start power group 59. Start power group 60. Start power group 61. Start power group 84. Start power group 85. Start power group 86. Start power group 87. Start power group 88. Start power group
500 trillion particles, compressed by the magnets into two beams each thinner than a human hair, move round the ring at the speed of light, producing 1 billion collisions per second.
A quel momento, in questo spazio molto piccolo, con quella grande densità di energie, tutta la fisica, tutte le leggi di natura sono lì presenti.
After billions of collisions, something turns up in the LHC detectors. This curve reveals the possible presence of a new mysterious particle. In less than a month, the physicists put forward 400 theories to explain it. How to choose between them? How will the right theory be recognized?
Some of the basic laws of nature explaining, for example, quantum mechanics, or explaining the behavior of the atom, or the way that the planets go around the sun, or how the universe expands. The concepts are very simple. How, with such few concepts, so simple, you can explain so much?
In a very, very, very simple way, we've managed to boil down this incredible amount of complexity into the universe into just 2 or 3 fundamental aspects. And to be able to do that is just kind of a form of magic.
When the solution is simple, God is answering, Einstein said. Behind the complex formulae, there is an intuition that the universe is hiding something extremely simple. To arrive at that simplicity, physicists use experiments and equations, but often that's not enough. Often they need something else.
There seems to be some aesthetics in the way we work. For example, when you look at Einstein's description of how gravitational forces work, it gives you a sense of beauty, aesthetics, because of the simplicity.
A theory in physics will have to be beautiful in order for it to have much truth in it. Einstein's general theory of relativity, that's so beautiful. It's so beautiful that I find it very difficult to understand.
It seems strange to me to hear scientists talking about beauty. Beauty has to do with taste, with personal feelings. How can it help a scientist?
Physicists I think they tend to look at theories and equations in a similar way. So if they're elegant and in a certain way pretty, appealing to them, then to us it's an indication that they're somehow right.
Il segreto del fisico è quello di capire che cos'è la bellezza. Non c'è una definizione matematica della bellezza, però la vedi quando la incontri.
there was this incredible sunset, one over the valley in the back of the mountain and one looking directly at Mont Blanc. And I kept looking at it and I couldn't figure out what was so... I knew it was beautiful and I knew it was attractive and I knew I just kept wanting to look at the mountain and just look at the scenery. And I kept thinking to myself, why do I like this so much?
Why would a sunset be beautiful in the first place? And you could kind of break it down like scientists and say, well, it's red because of Rayleigh scattering and the blue photons are scattered at hard angles so that it doesn't get through to your eyes to see it. And so you can all kind of break down why it looks this way and why it does that, but there's no inherent beauty in the actual thing itself. So the beauty would have to therefore be coming from the conscious mind. So beauty, I guess, would be a beautiful thought.
If the solution is simple, if there's nothing which you can remove anymore, if it's kind of reduced to the core, so that's beauty for me.
What attracted me to physics was basically that we don't understand how the universe is created, where it is going to. I think the mystery of the universe makes it beautiful.
I'm very keen on finding out if there's simplicity behind the world we see. We see a lot of forces, we see a lot of particles, and more particles get discovered. But what we need to do as physicists and as humans is understand the world in its most easy sense.
Don't know the beauty. I cannot describe it.
탐구해서 무언가를 찾아내는 것, 그래서 뭔가 새로운 것을 발견해내는 것, 그런 게 아름다움이라고 생각합니다.
The beauty that I see is the beauty of the creation of our mind. How a person's mind could develop such skillful skills, like how someone could think of beyond, out of your mind.
I think it's difficult to describe beauty in physics, in science, in general. Often it is not something which just you see with your eye. It's something that you feel with your brain.
Beauty is in the eye of the beholder, runs the proverb. I wonder, where else could it be? In which detail? Others say one can never know where it is, because it is just a secret harmony, a relation between things.
Uno vede nei fiori. Perché il fiore deve crescere con queste forme simmetriche e non in una forma casuale? E il più delle volte esiste una spiegazione ingegneristica, nel senso che il fiore ha un vantaggio nel crescere in quel modo. Nelle leggi fisiche scopriamo anche lì delle proprietà di simmetria. In qualche modo sembra che la natura sia attratta dalla presenza di simmetrie nelle sue creazioni.
C'è una bellezza. Di bellezza cosa vuol dire? Una ricorrenza. La simmetria che cos'è? È il trovare una ricorrenza, trovare dell'ordine all'interno del caos.
It is remarkable that the laws of nature have a symmetry that we cannot see with our eyes and we cannot see with simple instruments. So this is the hidden beauty we are looking for.
Is this the secret of nature? Is it symmetry that protects us from chaos? Where did the intuition of the Greek temple come from? Its parts are in mathematical relation, one with the other, as in musical harmony. Elementary particles have relations between one another which are more like those of a temple than those in nature that we can see with the naked eye.
Ora ci siamo accorti che in ogni passo dell'universo questa simmetria ha trovato delle piccole screpolature, delle rotture.
I think a completely symmetric world would not be very interesting. Life would be impossible.
La simmetria totale, la simmetria perfetta rischia anche di essere paralizzante, perché ti impedisce, non ti dà modo per cambiare le cose.
You might say that the beautiful universe is the one where all the symmetries are respected, nothing is broken. However, the beautiful world we live in is where somehow all the symmetries are in a broken phase. people often are more attracted to men or women who are not necessarily representing perfect beauty. So it is the asymmetry and imperfection that makes the person attractive.
I think that if you look at a sort of composite image of the Mona Lisa in which this part is reflected to be the same as that part, it would not be a very interesting picture. So I think that this idea of broken symmetry is something that artists also understand.
The story goes that carpet makers would deliberately weave a slight defect into their symmetrical designs. They were afraid that if the symmetry were too perfect, their souls would be trapped in the carpet for eternity.
Il concetto di bellezza sembra completamente estraneo alla scienza. E questo è completamente falso. La natura, nella formulazione delle leggi fisiche, cerca sempre una semplicità estetica. E il gusto estetico della natura non è così diverso dal nostro. E anche la nostra immaginazione è così tanto parte della natura che ha assorbito gli stessi canoni estetici che determinano le leggi fisiche.
Credo che la bellezza sia obiettiva, sia indipendente da noi. Sono i nostri sensi che la percepiscono, ma secondo me è già lì.
I think that the universe knows nothing about beauty. It knows nothing about people. It knows nothing about consciousness. Scientists and people perceive beauty in the universe. But I think that this concept of beauty is for me a human construct.
One thing that is interesting is that Weinberg, who certainly is someone who admires and likes the beauty that we see around us, says something that is shocking, and many people find it shocking, which is that the more we know about the universe, the more it seems pointless. That means that we begin to learn that somehow the laws of nature have no purpose.
There is an infinite spectrum of shades of beauty. Beauty, to me, is the abyss, that which cannot by any means be defined or categorized or simplified. It is something that is transcendent.
I prefer truth to beauty because I think truth has less to do with taste and more to do with fact. And I think this is true in science in the same way that science has escaped from traditional ideas of beauty, and the reassurances of those notions of beauty are over, and we are left with, yes, doubt as our yardstick.
Humans are predisposed to see beauty, and maybe that's the most interesting thing, is that we detect beauty. And the LHC is a giant detector. It's detecting something else. Maybe that is what it's detecting, is the foundation of beauty, not just the foundation of matter.
The heart of matter is free, unpredictable. Billions of collisions, and every time the result is different from before. Here, matter shows its character of energy and dance. The search goes on. No one can know whether the LHC will reveal a fresh surprise in a month, a year, or never again. I've come to understand that true scientists love, above all else, what they do not yet know. We are ministers of doubt, one said to me.
È un'attesa ovviamente molto eccitante, molto piacevole, è un'attesa semplice perché noi siamo abituati ad attendere per periodi di 20 o 30 anni. Per l'Higgs si è atteso per decine d'anni, per la supersimmetria abbiamo atteso per 40 anni, stiamo ancora aspettando.
Scientists are not afraid of chaos and uncertainty. But when telling a story so as not to get lost, you need something that puts things in order. Every story has an ending because human beings have a weakness. They always try to see a meaning in things. Not far from Geneva, 40,000 years ago, somebody ventured into this cave in the south of France. We do not know exactly why. There is a widespread tradition among many peoples that if a hunt is to be successful, it must be preceded by a vision. Of the human beings who painted these figures, we know nothing. The only thing we can be certain of is that they retreated from the visible world to trace images of nature made of order and beauty. In the darkness and silence of a cave, they held their breath and then blew spittle and paint onto the rock.